We found one-dimensional center masses. So now let's try to extend it into 2 dimensions. So let's just start off with an example. Let's say that I had a thing here. Here was 5 kilograms. Here's 2 meters. Here's 10 kilograms. Right, here's 2 meters. This is 2 meters. This is, let's say, 20 kilograms. 2 meters again. And here we have 40 kilograms. And let's say we want to find the center of mass of this system. And maybe this entire thing rests on a coordinate grid, right? Where this is the point 0, 0. If this is the point 0, 0, that means this is the point 2, 0, because we moved horizontally 2, right? 2 meters, 0 meters. Same with these, we can find the coordinates. Alright, yeah, so we can find the coordinates along there. So, let's say the problem asks us to find the coordinate of the center of mass. How do we do that? Well, we know that our one-dimensional center of mass is given by this equation, I equals 1. So we integrate for each discrete particle, right? Remember these things I said are particles, mi, ri, all over m. Right? So now, we just have to do this, but somehow apply it to 2 dimensions. So what we can do is, we can imagine this as like a piece of paper. And if I rotate this piece of paper so it's like completely flat, well, what happens? Right, this 20 kilogram mass and this 5 kilogram mass, it's like they stack up. And this 40 and 10, it's like those two stack up as well. So we get a system that kind of looks like this. 25 kilograms, one-dimensional rod, and then 50 kilograms. Okay? So that's, right, I've rotated. So let's say I wanted to find the center of mass here. Right, find the center mass of this system. Well, applying my equation, and let's say I pick this point to start with, I get 25 times 0 plus 50 times 2, so I get 100 kg times m, right, 100 kg meters, divided by the total mass, 50 plus 25 divided by 75 kg, and I get 4/3 meter. Right. So my center mass is 4/3 meter from here. Right. But how does this translate here? Well, that's as if we took, it's as if we said, okay, 4/3 meter, so we just moved 4/3 meter from here to here, right? We move, let's say my marker represents the center, where I think the center of mass is. I move along, and here's my center of mass. When I rotate it, my marker draws a line. It's as if we're moving a marker, a line across here, and we're saying the center of mass is somewhere on this axis. Did we find the coordinate? Yeah, no. We only know that it's somewhere along this line. Then, what we do is we do the same thing, except we now want to find it along this line. So we can find where it intersects. Where the two lines intersect is where we can say our center of mass is. So let's do it for this line. Right? So on the bottom, I would say I have 60 kilograms. Right? I have a 2 meter rod. And on the top, I have 15 kilograms. Right? So if I do my center of mass calculation, and let's say I start here, I would do 15 times 2, so I say on the top I got 30 kilogram meters. On the bottom I got the sum of the whole thing, which is 75 kg. Makes sense that we got 75 kg for both of them, right? Because the total mass of the system is 75, and we're not changing the mass, we're just changing our orientation in the way we're looking at it. So 30 over 75 is equal to 30 over 75, 2/5. So we got 2/5 meters. So we move 2/5 meter up here, and there we go. Here is our center of mass. How do we write that as a coordinate though? Well, I said, right, we moved 4/3 meter to the right. So I say 4/3 meter from 0, 0, so 4/3 is my x-coordinate. My y-coordinate, I moved 2/5 meter up. Bam! There's my coordinate. All you have to do, right, is you just think of the system. You find two lines where it intersects, and that is going to be the center of mass. For all of these discrete two-dimensional systems, this is what you have to do. And I don't think the AP test is going to get harder than this. Maybe they'll throw in a three-dimensional system. Well, for a three-dimensional system, what you would have to do is, right, let's say we have a box. Instead of thinking like we draw a line for a center of mass, right, we rotate it and we get a line. This time, if we draw a center of mass, we get not only a line here, but a line here. So we get a whole plane. That's where our center of mass is. We think our center of mass is. So where three planes intersect is going to give us a point. So for three-dimensional, we just have to apply the same exact process, except 3 different times. And yeah, so that's pretty much it. That's how you find the center mass of multidimensional systems. Alright, have fun. Good luck. AP test is very soon.